Okay, we're going to continue with our 5-3 solving trig equations. And just to review, the period of sine and cosine is 2 pi and the period of tangent is pi. Now, when we get to these kind though, where they're asking you to find all solutions in the interval 0 to 2 pi and you're not finding all solutions, even with tangent, you'll still want to list the solutions that are between 0 and 2 pi because that's a finite number of solutions. It's not an infinite number. So you'd want to list each one separately, okay, even though it does repeat. So I don't know why I did A and B on this page because I had plenty of room over here. But we're going to do example C. Now what we're doing now is solving by factoring. So example C, example 3C. Is 2 sine x cosine x equals the square root of 2 cosine x.
Let's say 2 sine x.
2 sine x cosine x equals square root of 2 cosine x. So let's go ahead and set it equal to 0 by subtracting square root of 2 cosine x from both sides. So we have 2 sine x cosine x minus the square root of 2 cosine x equals 0. Okay, now we can factor because this term and this term have something in common. What do they have in common? Cosine x. So we can factor out cosine x and we'll have 2 sine x minus the square root of 2. Now, we can take both of these factors now and solve each factor. So we have cosine x, set it equal to 0. So some of our solutions are going to be when cosine equals 0. So your unit circle, you'll need your unit circle if you don't have, forgot to remind, or yeah, I didn't remind you. All right, cosine, good, is your x value. So x is 0 at pi over 2 and 3 pi over 2. Okay. Now let's do 2 sine x minus the square root of 2 equals 0. So we're trying to isolate sine x. So the first thing you want to do is add square root of 2 to both sides. So we have 2 sine x equals square root of 2. Now what do we do to divide both sides by 2? So sine x equals the square root of 2 over 2. And it's just positive square root of 2 over 2. So look at your unit circle. Sine is your y value. Sine will be y values. So if you look, you see a positive square root of 2 over 2 at pi over 4 and 3 pi over 4, correct? Then down here they're negative. Yeah. So x equals pi over 4 and 3 pi over 4. And we're just doing the solutions between 0 to 2 pi. So you don't have to put the plus 2 pi in and all that because we're not finding solutions from negative infinity to positive infinity. Oh, I actually have another one. I just realized that. Maybe that's why I did that. I have a 3D. Let's go ahead and do it. I almost didn't leave myself enough room. And I know there's a lot of examples here, but because there's so many different kinds of equations and different ways you can solve them, I wanted to try to give you a good, set of examples. All right, so this one is 4 cosine squared x plus 2 cosine x minus 2 to the square root of 2 cosine x equals the square root of 2. Wow.
We can factor out a cosine x.
We can actually factor out more than just the cosine x, you're right. We can factor out 2 cosine x, good. So 2 cosine x. So then we would have, we'll do that in just a minute. Well, no, because if we did, we couldn't factor out a 2. So it's better to go ahead and factor it now. Wait a minute. Yes, we do. You are right.
Why?
Yep, you're right. And then we factor by grouping. We're going to need that other one in there so that we can factor it. Because it needs to be set equal to 0 before you factor it. You're right. Anytime you factor, you set it equal to 0. Thank you, Bailey.
So you're videoing this?
Yeah, that's okay. Not the first time I made a mistake. If I was just going to video every time it was perfect, I'd be not videoing very often. Okay, so we have 4 cosine squared x plus 2 cosine x minus 2 to the square root of 2 cosine x minus the square root of 2 equals 0. Now we're still going to be factoring. But we're going to be factoring by grouping. Now, do you want me to do one with just an x in it so you can see how it works? Because it's been a while since we've done that, or just go with what we're doing?
Just go with
Okay. All right.
It's been a while.
So we want to group these two together and these two together. So here we can factor out a 2 cosine x, right?
Mm-hmm.
And what do we have left? 2 cosine x plus 1. And here we want to factor out a negative square root of 2 because we have a square root of 2 in common. So that would make this a positive 2 cosine x. And then this sign is going to change because I factored out a negative. So it would be plus 1 equals 0. Okay, now we have 2 factors. Now we're going to factor out another GCF again. So we have 2 cosine x plus 1 in common. So factor it out. And then what do we have left on this side? 2 cosine x, and over here minus the square root of 2. So your other factor is made from what's left over. Now we just set these equal to 0 and solve. So we have 2 cosine x plus 1 equals 0. Subtract 1. Divide by 2. No, it's just going to be negative.
Right.
Because we didn't take a square root. All right. So cosine is equal to negative 1/2. So look at your unit circle. Now what are you looking for? Where are you looking for a 1/2? X. And you want a negative 1/2. 2 pi over 3. And 4 pi over 3?
Yeah.
Isn't that right? So x equals 2 pi over 3 and 4 pi over 3. It's part of our answer. Now we want to set this one equal to 0. 2 cosine minus the square root of 2 equals 0. What do we want to do first? What?
Add the square root.
Good. Add the square root of 2. So 2 cosine equals the square root of 2. Then we divide by 2, and we get, whoops, I forgot to put my x. Just leaving my x out all over the place. So cosine x equals positive square root of 2 over 2. Now cosine is your what?
X.
X. So look and find positive square root of 2 over 2 in your x. Pi over 4 and 7 pi over 4. The other two quadrants, it's negative. So x equals pi over 4 and 7 pi over 4. Now, I went ahead and put this one in here, but we're not going to do this right now because you have to have some, I just lost the word I'm looking for. You've got to have worked with inverses some, and we haven't done any inverses. So we're going to put this problem on hold. Okay, we may come back to it at some point. But for right now, we're just going to omit it. But I went ahead and put it on here because it's actually in the notes. Experience, that's the word I was looking for. You have to have had experience with trig inversions.
So, are we on the back?
Yes.
Oh.
But look. Hey, but look.
Hey,
Wow, what's wrong? Okay. Hey, example 5A. And like I say, I normally don't do near this many examples, but you need a good bank or set of examples. So this time we're going to be doing some rewriting with our identities. So you might want your identities out too.
I was wondering why we were doing example 6.
2 cosine squared x minus sine x minus 1 equals 0. Yeah, I know, Bailey. I'm about there myself.
I'm already there.
Now this one's already set equal to 0.
Yeah. Oh.
So, you know, I could try to factor it, but I've got cosine and sine involved. So I can't factor if I have cosine here and sine here. I need to either have all cosine or all sine. So what you can do, if you look at your Pythagorean identities, I believe we could rewrite cosine squared x so that it has sine in it instead of cosine. So let's replace, that's what it talks about when it says rewriting. We're going to rewrite cosine squared x as 1 minus sine squared x. Everything else stays the same.
1 minus sine squared x minus sine x.
Yeah, that almost looks like a plus because my pen gets minus. Now, what do you think our next step might be?
The next step would, yeah.
How we get rid of the parentheses? Starts with the D. This. This. Trib. Distribute. So distribute your 2. So you have 2 minus 2 sine squared x minus sine x minus 1 equals 0. Now I see some like terms. I see some constants. I see a 2 minus 1. What's a 2 minus what's a 2 minus 1? What's 2 minus 1? Okay, but I'm going to write it so that my sine squared is first. So I'm going to put the 1 at the end. So I have negative 2 sine squared x minus sine x, and it was a positive 1, right? 2, yeah, plus 1 equals 0.
All right, now.
Now, we're going to factor this here in just a second, but before we factor it, we need the sine squared x to be positive. So we want to factor out a negative 1, which would change all of the signs. So we have a negative outside the parentheses, then we have 2 sine squared x plus sine x minus 1. Now, I want you to look at this. Okay, what if we had 2x plus x minus 1? And I wanted to factor that. Okay, well, I need two things to multiply to give 2x in the front. So 2x and x. Okay, then I need two things that'll multiply to give me negative 1 here, but when I do my outside and inside and add them together, I get a positive 1. It's got to be 1 and 1, right? That's the only thing I'll multiply. And we want
2 negative ones.
Well, if we do 2 negative ones, then we'd have positive 1 here. So the 2 needs to be positive
and 1 needs to be
negative. I'm videoing this, dear. I'm videoing this.
Yeah, you just ruined the whole video.
No, we don't.
We're going to start all the way back from
The kids in AEP will go, I hear Monica. Really, yeah.
I hear Wesley now, too.
Yeah.
Oh, I'm leaving on you.
All right. So 2x minus 1x plus 1. Okay. Same thing here. It's just instead of x, we have sine squared x. Oh, this should have been x squared. Sorry. That should have been x squared. Instead of, yeah, it makes sense. More sense, doesn't it? What? I thought you were over here talking to somebody. You talking to yourself?
I'm not even talking about it.
You were.
You're hearing it.
No, I don't think so. All right, so same idea. Put our negative. So we have 2 sine x and sine x, just like we had 2x and x. 1, 1, and we want the 2 to be positive and the 1 to be negative. So when we add them together, we would get 1 sine x in the middle equals 0. Now we're ready to solve. Now this negative out front, we don't even have to worry with it because we're solving for x. And there's no x with the negative 1 of any kind. So we can ignore that and we just need to solve for these two. So we have 2 sine x minus 1 equals 0 and sine x plus 1 equals 0.
I need to borrow a calculator for essence, but Mr. Petty would only let one of us leave at a time. So
When is she going to bring it back? Do you know?
after this class or something
Okay.
like that.
Yeah, get one. Go ahead and write her name up there and the number. All right. So what do we need to do on this side first? Add 1. So 2 sine x equals 1. Then what? Divide by 2. Right, Wesley?
That's what I would do.
Okay. So we have sine x equals 1/2. So to your unit circle, what are we looking for?
Sine x equals 1/2.
I know, but what sign?
So sine is y.
Sine is y. Positive 1/2.
Positive 1/2, which is pi over 6. Also is 5 pi over 6.
Anywhere else besides pi over 6 and 5 pi over 6? Nope, they're negative in quadrants 3 and 4.
Yep. So that is our answers.
So x equals pi over 6 and what?
5 pi over 6.
Well, that's part of our answer.
Oh, snap.
Now we need to do this one.
Oh, yeah.
So subtract 1. Sine x equals negative 1.
Sine x equals negative 1. 3 pi over 2. 3 pi over 2.
3 pi over 2, and that's it, isn't it?
Yep. Ooh.
Now we could check this with the calculator. What you'd have to do is change these to decimals because the calculator works in decimals. And then look from 0 to 2 pi, which is like 0 to 6.28. And you can figure it out. It should cross the x-axis 3 times. If you put this whole thing in. We may do that later, but not right this minute. All right, we've got a 5b and a 5c.
Oh. I have room for.
Well, you see, I had to do a lot of squeezing in. Of course, I messed up right there on 5c. So on my notes, I did 5b, then I went down here, and then I left a little room over here to do my 2 example 6s. So 5b.
We're not 5b, 5c, and 6.
Well, you can use a piece of notebook paper if you need to and put it on notebook paper.
5b. 5b took up half my room.
All right. Now, I didn't say this a while ago, but the instructions are find all solutions on the interval. Whoops, that should be a bracket. 0 to 2 pi. Okay. I need to be watching over here closer because I may have gone off the screen a few times. Okay, 5b. 1 minus cosine x equals 2 sine squared x. Now, this is still the section where we're going to be doing some rewriting. So what do you think we might be rewriting here?
Change sign.
This right here?
Yeah.
So 1 minus cosine x equals 2 times 1 minus cosine squared x, right? Now what? Then what?
Do we need to set it equal to 0?
Well, we got these parentheses we need to do something with.
Oh, distribute properly.
Good. So we want to distribute the 2. 1 minus cosine x equals 2 minus 2 cosine squared x.
And then you.
Okay, now we want to move to the other side. Now, our cosine squared is negative, so it would make sense to move it over here. So we would have 2, I'm just going to do this one step at a time. 2 cosine squared x minus 1 minus cosine x equals 2. I mean plus 1, sorry, thank you. I was getting ahead of myself, because now what are we going to do to set it equal to 0?
Subtract.
Subtract 2. Now let's put this in the right order as we do this. Let's put cosine squared, cosine, then constant. So we have 2 cosine squared x minus cosine x, and then 1 minus 2 would be negative 1 equals 0.
Okay, after that.
And now what do you think?
Now, we can, let's see.
Factor.
We cannot factor.
Yes, we can.
No,
Yes, we can.
no. You can't take cosine of 1.
All right.
Oh, different.
Not factoring out the GCF.
Oh.
All right. 2 numbers that multiply to give me 2 cosine squared x would be
Cosine x.
2 cosine x and cosine x. Then our only option to get 1 is 1 and 1. But this time we want a negative cosine x. So we want when we multiply the outside, we want that to be negative if we were foiling it back together. Right?
Yeah.
Now we're ready to set each one equal to 0. 2 cosine x plus 1 equals 0. So 2 cosine x equals -1. So what is cosine x? -1 half. You got to divide by 2. So cosine is where again on your unit circle? X. So you're looking for -1 half.
So
Yeah, so that's two pi over 3,
2 pi over 3.
7 pi over 6. And that'll be it.
7 pi over 6.
and
Now you're looking for the x
4 pi
value.
over
4 pi over 3. You were looking at the y value. We're looking for x. So 4 pi over 3 and 2 pi over 3. So x equals 2 pi over 3 and 4 pi over
This
3.
one, your cosine will equal 1.
So cosine x minus 1 equals 0. Cosine x equals 1. Good, you're working ahead of me. So when is your x 1?
0.
At 0. Okay, are we having fun yet?
Too much fun.
I'm having lots of fun
Good. We can just do more and more and more.
up until this time. And I hate to leave.
All right, 5C.
Okay.
Cotangent squared x. Cosecant squared x. That's times. So that's one term. Cotangent squared x, cosecant squared x. That's one term because they're it's a product. Plus 2 cosecant squared x
Oh, shit.
minus cotangent squared x equals 2.
All right, really slowly, read that back to me.
Cotangent squared x, cosecant squared x
Mm-hmm.
plus 2 cosecant squared x minus cotangent squared x equals 2.
Cotangent squared x? Minus 2.
Why is that flickering? Look at this. Don't see that? It's flickering. It usually does that here, but it's not. Why is it doing that?
Here, all it needs is a little bit of Wesley. Oh, no. Okay, I'm out of it.
Wesley.
I stopped it, though, didn't I?
Nope. Still doing it.
Yeah. Well, I guess I just get to see white and blue.
I don't know why it's doing it. Oh, I got it to stop. I moved it a little bit. Okay.
That was me.
Okay. The first time I tried to change cosecant squared x to cotangent squared, but we figured out real quick that wasn't going to work as well. So what I ended up doing was I changed my cotangent squared to cosecant squared minus 1.
Just blinking.
Okay.
Great.
All right. So let's rewrite
Blinking.
this. I don't know how to stop it.
I guess I'm going to call and tell you to
This is next.
Hello? Uh-huh.
Bring Wesley to the office, please.
Okay.
Send him to the nurse. He has to go home.
Right. Yeah.
Yeah.
Yeah, that's fine. All right. Thanks. Bye-bye.
Yeah. You want to go now or later?
Why is it doing that? Okay. So look at your identities. What is cotangent squared x equal to in terms of cosecant? 1. Is it 1 minus or?
Cosecant minus 1.
Okay. Cosecant squared minus 1. So we have cosecant squared x minus 1. That takes the place of this. times cosecant squared x plus 2 cosecant squared x minus, and then we're going to replace this cotangent squared with cosecant squared x minus 1.
Well,
Now we're going to distribute this
oh,
and distribute our negative to get rid of those two sets of parentheses. So we have, cosecant to the 4th x, right? Is that a minus 1 or it's a minus 1, isn't it? Yeah. Minus cosecant squared x plus 2 cosecant squared x minus cosecant squared x plus 1 equals 2. I left my equals 2 off up there. So now I need to do some combining. I've got negative cosecant squared x plus 2 cosecant squared x minus cosecant squared x.
2 cosecant squared x.
First year would just
Yeah.
become
2 cosecant squared x plus 1.
nothing. First year, I'll just cancel out.
You're actually right. You were just guessing, weren't you?
No, because there's 2 positive and 2 negative.
And see, that came through and it started blinking again.
Minus 2 cosecant.
All right, see, this would be negative 2 cosecant plus 2 cosecant. So they cancel out. It's like negative 1 plus 2 minus 1. Then we want to subtract 2 from both sides. So we have cosecant to the 4th x minus 1 equals 0. Now, what if I did this? What if I gave you x to the 4th minus 1, and I wanted you to factor it? What would you do?
You would add 1 both sides?
No? How would you factor that right there? It's a difference.
Squares.
It's a difference of squares. It'd be x squared plus 1, x squared minus 1, correct? So same thing here. It's going to be cosecant squared x plus 1,
How'd you get that?
difference of squares.
Oh, where'd your 2 go?
I subtracted 2 from both sides.
No, but your 2 is multiplied into the.
What are you talking about?
It says 2 cosecant squared x.
These canceled each other out. We added them together. Negative 1 plus 2 minus 1. What would negative 1 plus 2 minus 1 be?
0.
So all the cosecant squareds are gone.
I'm talking that right there.
Well, these two are negative 2. That's negative 2. When you
Yeah, but then
those don't cancel each other out because they're both negative.
no, but this one cancels both of them out.
That's a 4th. It's not a squared. They're not like terms. You can't add those together. It'd be like trying to add an x to the 4th to an x squared. Can't do that. They're not like terms.
Oh, come on. Really? We did all that work?
Oh, you already got it?
Yes.
So cosecant squared x plus 1 equals 0. So cosecant squared x equals negative 1. Now we have to take the square root of both sides, and what happens?
Nothing, because it's imaginary, and we're not dealing with imaginary.
So there's no solution, right? Now,
That's what I got.
when we look at our unit circle, cosecant is the reciprocal of sine. So you're going to have to take,
Right, whenever we do squares. So we're going to have to tell me almost.
what?
So wait, do you change it to sine squared, 1 over sine squared x?
What you could
first?
do, since we're setting it equal to 0, this is the same as tangent squared, isn't it?
Yes.
Wouldn't that make it a lot simpler if we just
Yes.
set tangent squared x equal to 0? Otherwise, we'd have cosecant squared x equals 1, and then we'd have to get it figured out. All right. So when is, we got to take the square root. So tan x equals 0. No, this isn't imaginary. So square root of 0 is 0. All right. So when is tangent equal to 0? Now on your unit circle, what is tangent?
Sine over cosine.
Which would be
Y over X.
y over x. So when you're going to be looking at these 4 right here. All right. Would this be 0? 0 over 1?
Yes.
Yes. Okay. So x can be 0.
Hold on.
All right. Wait, something's weird here. Okay. All right. What about here at pi over 2? 1 over 0. Would that be 0? No, that's undefined. All right. Then here at pi, 0 over negative 1. Would that be 0?
Yes.
Yes. So 0 pi. Then what about down here, negative 1 over 0? That would be undefined. Whoops. So x is equal to 0 comma pi. Okay, we'll stop right there.
Oh.
MD signing off.